find your seats, and I think we. All right, good morning, everyone, and welcome to Monmouth University. It's great to see so many familiar faces here and new faces, so welcome if you haven't been to campus before. Little housekeeping, if you haven't found the restrooms, the ladies' room is out the main door here to the left, and the men's room is to the right. So that buffet breakfast is out there all morning, so help yourself if you want another cup of coffee or a bottle of water or anything. And I think that's where we'll have the lunch set up as well. So, well, this is our fourth workshop on the coastal lakes. It's, it's quite amazing that we've made it through the pandemic and kept sampling. So congratulations to you guys for staying persistent, having something to do during the pandemic. These past 4 years have been really engaging for us. We started with an idea that if we started to monitor our coastal lakes, to collect the data that could be used to eventually look to restore our lakes, that we would be able to effectuate that in the future. So we're really happy that the Plangier Foundation has funded us for 4 years through 2 grants to allow us to continue to work with you and your communities and with your lake groups. And the data you've been collecting is now telling a very compelling story. And Professor Adolf will tell that story later today. But the information now allows us to think about how we may want to restore our lakes, right? And so if you remember, if you were here for the first workshop, I want to say in 2019, thank you, Erin, we started out by saying we just don't want to collect data to collect data. We want to collect data to be able to use that information to begin to think about how best we want as communities to restore the lakes. And the data is here now that we can leverage and approach people that are interested in helping us restore those lakes. So we'll hear from Marty McHugh later today about some of the restoration projects his company's been working on and some of the ideas restoration ecologists have on how we restore these systems. And along with that, through 2 very important bills that were passed by Congress in the past year and a half, the Infrastructure Act and the Inflation Reduction Act, the federal government has put significant funding aside for ecosystem restoration and resilience. And these funds will be available for the next 5 years. So we're talking tens of millions of dollars the federal government has in place right now to help communities like yours restore your ecological functioning of the lakes. And so it's an opportunity that we have set ourselves up for to take advantage of, right? So by our hard work in collecting the data, we have the baseline to make a compelling case to funders why we need to restore these lakes and how we can best do that. And so hopefully by the end of today, you have some excitement and knowledge to think about how we may want to pursue that in the future. And here at Monmouth, we are willing partners with you. We would be happy to help each of your communities navigate processes, the funding processes, the proposal processes. That's what we do at the Urban Coast Institute. That's primarily all I seem to do is write proposals to help conduct the work we really want to do, right, as communities. So hopefully at the end of here, you leave with more excitement than you usually have. This has always been a great group to work with, and we learn so much by talking to each other. But now we'd like to advance the ball a little bit into the restoration sciences. So with that, welcome again. I know Tony MacDonald is running a little late, so do you want to move over to the agenda? So the next portion of the agenda then, which gets best on time, is Erin will give us a CLONet overview, we've been working on over the last year. I think you all know Erin, because she's probably been your most efficient partner. She's always there to help you, and so, Erin, you want to give a...
Hi everyone, I'm Erin, if you don't know me. I'm the Citizen Science Coordinator for CLONet. What I'm going to be talking about is just how we started, what we're doing, and what we hope to do in the future. So just to start off with all of the coastal lake issues that we face, we have algal overgrowth, HABs, and nutrient eutrophication. Algae is just a natural part of these ecosystems, but once it starts to get all these nutrients, they grow a lot more. You see, I'm sure all of you have seen in our lakes over the summer, they get kind of green. Sometimes they get some scum growing on the top. That picture is from Lake Como over the summer. It started with a lot of grass clippings entering water, and then it kind of took over and grew into that lovely mess. So the issue with all of these algal overgrowths is that they grow. If they grow too much and they start dying, that's when you see low oxygen levels in the water. And then you can see fish kills, the water might smell, stuff like that. Also, they can be toxic sometimes when the HABs come in. Stormwater runoff can either increase the temperature of the water or bring in the nutrients. Sediment infilling is a problem. It increases the turbidity, makes it harder for the organisms in there. You have microbial pollution and floatables, depending on how big they are. For floatables, can either just be an eyesore or it can be damaging to the organisms living in the water. So there's some history of the coastal lake work at Monmouth. In 2008, we had a coastal lake summit, and the goal of that was to review the status of the coastal lakes and all the problems that we have, most of the ones I just listed, and issues with lake management efforts. And they kind of found that all of these lakes had the same issues, but that doesn't mean they all have the same solutions, so they kind of have to work individually but also together, so it's a complex issue. And the goal, or the point that they made, was there's a very disjointed path, so you have all of these different partners and communities working on issues in these lakes, but nobody's really talking to each other about them, so they're all doing independent things and having their own findings, but nobody's discussing what they've found. And then 2 years later, they had this paper published, and it outlined restoration techniques, best management practices, how to improve water quality, habitat quality, and overall lake health. It was recommended development and implementation of regional coastal lake management strategies. And then 2012, we just had our 10-year anniversary of Hurricane Sandy. It really had a big impact on our coastal lakes. Those are some of the photos from then. So in 2013, they held a coastal lake summit to discuss problems and how to come back from that. So in 2019, we skipped a few years, CLONet began. The initiative for that was to foster the development of community-based participatory research and restoration groups that will allow communities to address coastal lake issues based on their own knowledge and use of underlying scientific data, which I'll talk a little bit more about in a couple of slides. The overall goal was to establish a water quality database. So for all of these ecosystems, it's really hard to do restoration work if we don't know the standard water quality of it and just how it, how it is. We want to engage the communities. You get a lot farther in restoration techniques if everybody around these lakes cares about it and is willing to give up certain things in order to see improve of water quality. And the goal is to end the disjointed path by opening communication between lake partners. As kind of an overview of how the system works, so ideally, we are in the center, Monmouth University. We supply lakes with supplies to test the lakes for water quality, and they give us the data back. And then over time, we turn that data into something that you can use to apply for grants or just look at and see the overall water quality of it. We have state partners, we have our citizen scientists, and we have lake commissions, among other people working with us. Yeah. And these are the parameters we measure. So first we have Secchi depth, that reads water clarity. It's one of the most important measurements we have. So the goal is you lower that disc into the water until you can't see the white anymore. And that gives us an idea of how deep the light goes in there. And light is important because that fuels all life in the water. We measure temperature, which is important because certain temperatures breed certain phytoplankton in the water. And conductivity is kind of like salinity. Most of these are freshwater lakes. Sometimes you get more effect from the ocean in the lakes, depending on the tides. And we test dissolved oxygen, which is important because everything needs oxygen to survive. Sometimes it's really high, sometimes it's low. And phycocyanin levels, that is the top right meter. That measures phycocyanin, which is the pigment in cyanobacteria, which is what blooms in our lakes typically. And that's 1 per lake. This is our data sheet that we use. Some people like to fill it out on paper and then go home and type it in the computer there. Some people just fill it out on their phones. But all of the data gets put into this one place. And then I go through and perform quality assurance on that data, make sure everything's looking all right. That's where I come in. So I train people to use all of this equipment. I do yearly in-field check-ins, which we just started this year. I check the data quality and review the field notes. So if they saw something that was really weird in the lake, they'll note it down. I'll go through and look at that and put note into that something else. Just troubleshooting issues if you're having issues with your equipment. Say if your meter is not reading right, I'll go out and calibrate it. And I do waste disposal because the oxygen kits produce waste that I need to pick up and get rid of. And then I also supply new supplies. This new feature that we have, Jason will show you how to use it later, but on the website, if you go to the Data Explorer app, you can actually download the raw data. So if you have a group of students who want to do something with this data, you can go and look at it raw, and they can do whatever data analysis on it that you guys want. So it can make for good school projects. If you guys want to use it in your own way, feel free. These are just some photos of the citizen scientist training sessions in 2019. We used to do really big groups when we first started. Now, we don't have as many people coming in because we have a pretty good solid base of samplers, but we typically do one-on-one now. Sometimes it's a couple people, but I think it benefits them because they really get that one-on-one experience, and we make sure that everybody's doing everything properly. These are just some statistics for sampling. So sampling happens weekly during April to October, and then November to March, it's every other week. So ideally, we have 38 samples per lake per year. These numbers on the right are from November to November. And as you can see, we have a pretty good solid foundation for most of these lakes. Most of them only have one site, but Deal Lake has 2, and Silver has 2, and Lake Como has 2. And we just welcomed Jackson Woods to Lake Como. It's a bit north on Ocean Avenue compared to Lake Tackanassie. So they're just getting started with their sampling. But I think this year we did a really good job at maintaining our sampling efforts. So shout out to Sampler.
What's the difference between a station and an active site?
As over the whole year, that's how many stations were active at one point. So Deal Lake, there's 7 sites. There's currently 5 active sites. So we did lose Steve and Rita Niddle. They moved away. So one of their stations is not covered currently. And then another sampler kind of backed down a little bit. So overall, for the year, that's how many we had. And then current active, I did in the past 4 months. So the past 4 months, so that's pretty up to date. Then our hopes for season 5, we're kind of slowly changing our focus from only data collection to how can we restore these lakes, what do we do? We still want you collecting data. We really need that. We want to see how whatever restoration efforts you are picking, how they do change the lake. So we're looking for consistency still. And QAP is a quality assurance project plan. It's ready for review, we just gotta send it out. And that will hopefully help us get more grants in the future. And potential funding, it's a lovely graph. The Water Quality Restoration Grant Program under the DEP is potential sources for 2024 funds. I think, do we hear for 2022? Or are we waiting on those? I don't know. But acknowledgements. Thanks to the Jules L. Plangier Foundation for the grant that supports us. Thanks to DEP for nutrient analysis on the lakes. And thank you all of our citizen scientists. And that's it. Any questions?
Season 4, season 5, we mean year 5 actually, or?
Yeah. Starting November to probably next November.
American Literal Society tests Red Pond. I've been trying to get them to share the data. I just want to do it. I don't know if you've had any luck contacting them.
Not yet, no.
I said they actually attract fish. They do an inventory of all the fish in Red Pond, which is surprising but they also do testing in Red Pond. They have a good test kit there at the lake. You can go and open it up and take the test material out, test whatever you want, fill out the form and send it to them. They never see it beyond that.
Yeah.
I'd like to know what they find. Oh.
Thanks, Erin, and we're a little out of order here. I just had a little car trouble, but I'm here and everything's good now. So for those of you who don't know me, I'm Tony MacDonald. I'm the director of the Urban Coast Institute here at Monmouth University, and it's been really exciting to wait to see how this project has expanded. Very, very excited that we're kind of moving to really recognize that if we do this monitoring and we involve communities, we can actually think about restoration strategies. So really, I do want to emphasize something that Erin said is really in our discussions with DEP and other parties, they really want the information in order to be able to entertain options. And my guess is Marty will talk a little bit about this when you're looking at strategies to restore the lake. In order to look at different kind of strategies to restore your lakes, you really will need data to support that. DEP's not going to approve permits. They're not going to approve alternative uses of the lake, things like living shorelines, things for maybe some trade-off for fill versus hard structures. All of those things really need to be supported by data. So really understanding how this is and how this is accessible. I'm really so excited about the app and making this available to folks. So the more we can spread the word that this is something that is accessible to communities, the more we can build on the efforts that you all have been doing in a consistent way. And that's another thing. Thanks to Erin for continuing to support your efforts, because really the consistency of effort is really probably as important as anything else in this effort. And the fact that we've been able to sustain this and gain increasing interest in it really makes a difference. And that's as a result of the community stepping up. We've been approached from some local high schools who are interested in maybe getting involved. We're trying to figure out how we might involve some learning experiences around these lakes as well. And that I think is really going to be excellent for really getting enthusiasm within your communities for continuing to do the hard work and the hard investments. I have to say, you know, the thing that always kind of can overwhelm people sometimes is the prospect of dredging these lakes, but that's something that we'll put on the plate, and my guess is Marty will talk a little bit about that. But in the meantime, there's a lot of other things that we can do. We really can be better stewards of these lakes in terms of getting the communities engaged, thinking about living shorelines, reducing runoff into the lakes, think about nutrient reduction strategies that you can do within your communities in general, and generally raising public awareness about the ecological values of these lakes. So really making communities understand that. So I'll just say again, thank you for your efforts. Thanks particularly to Erin, who's really been the linchpin for connecting it, and to Professor Adolf, who will come up now, I think, and talk a little bit more about some of the strategies that he's going to work with you on. So It's just, and Tom Herrington, who's the Associate Director at UCI. So welcome to Monmouth. We are available, and again, spread the word. We have these annual get-togethers, but I do think, thinking about just picking up the phone or telling anybody in your community who's interested that we're available to try to answer their questions, and Erin is a resource for you. We'll hope you'll spread the word, and we'll continue to build on our successes. So again, thank you very much. Welcome. And Jason, I think you're up next, right? Great. Thanks. Welcome.
Morning, everybody. I'm Jason Adolf. I'm a professor of marine science here at Monmouth University and affiliated with the Urban Coast Institute. And I'm excited to be here in the fourth year. My job on the team is the data management and the data analysis, including the data that you collect and the data that we collect. And that's what I'm going to talk to you about today, with a focus on this transition from just monitoring to monitoring and restoration, monitoring through restoration. I want to acknowledge, I put the 3 CLONet members, myself, Tom, and Erin up top, but there are lots of other contributors, both from the DEP and from Monmouth University, listed below, including students who have come and gone. That's been one of the good things about this program. The students being here, not going away necessarily. Erin was a student. She's still around. She graduated in 2020. So when I think of restoration of coastal lakes, and I think of restoration, or coastal lakes in general, I think of like these old-timey maps. Can you imagine coastal lakes in the day? What they're like? So they're a natural feature of the coastal plain environment of New Jersey. The ones we're talking about are located where that red circle is there. Let me be sophisticated and get myself a laser pointer. Great Pond is Deal Lake. Whale Pond, further to the north here, you can't read it from where you are, but it's labeled Whale Pond, is Lake Tackanassie, Whale Pond Brook. It's a map from the 1860s. Think about the ecological and the social function of these lakes when they were pristine. And I don't know if restoration should try to get them back to pristine or just in that direction. But you know, if you've seen the old-time postcards of people sailing and boating and swimming in coastal lakes, that wasn't even that long ago. But also as habitat for anadromous fishes. You can see they're both openly connected to the ocean as an inlet there. So I think it's important that we remember that these are natural parts of the environment. New Jersey, of course, has changed since the 1800s. We're now the most densely populated state in the nation, including the area where coastal lakes are found. If you look at coastal lakes as they exist now in this Google Maps image, clearly it's not New Jersey of the 1800s. It's densely populated, suburban to urban watersheds. And as many of you know, the coastal lakes play a role by choice of the municipalities as stormwater basins. An important role because we don't want our streets to flood either. They're still connected to the ocean, except in a highly managed way, an engineered way. Pipes and culverts, electrified flumes, or Don Brockle running out in a rainstorm to crank it open, which days are gone. But that connection to the ocean is important both ecologically and in terms of environmental science because it means that what happens in the lake affects our swimming beaches. And one of the posters over here by Marie Morrow, who will be here at lunch, addresses that question, that one over there. So my research group has been interested in these coastal lakes since I got here, since I learned about Monmouth's involvement. And I've been interested in water quality, watershed issues, harmful algal blooms. And one of the first things that I noticed early on is how different the lakes can be, even though they're very near each other. And that's illustrated in this image of different colors of water taken from different lakes on the same day. Actually, that screen does a better justice than my screen. The color of the lake reflects the contents of the water, and you can see just by looking at that how different lakes can be. Spring Lake, by the way, is always that fluorescent green color. Has been for like as long as I've been looking.
Does that color reflect anything or say anything to you about the
I've looked under the microscope, and I don't think it's cyanobacteria, which would be the bad sorts of phytoplankton. It seems to be very, very small phytoplankton that you can't see very well with the microscope. It's kind of frustrating. Another thing that I've learned about coastal lakes through, I was a member and a co-leader of the New Jersey State Harmful Algal Bloom Task Force for the last 18 months, is where our coastal lakes stand in relation to other lakes in the state. And that's illustrated here. Deal Lake represents the coastal lakes. This is DEP data now. Compared to other lakes in the state that have had harmful algal bloom issues, coastal lakes tend to be more eutrophic and worse off, if I'm going to bottom line this. Secchi depths are lower compared to other lakes. Can you imagine seeing 10 feet through the water in like any of our coastal lakes? Total nitrogen and total phosphorus are both higher compared to these other lakes. So we're dealing with a rather degenerated system of lakes to start relative to other lakes in the state. And that's not surprising. So we're all here because we're all members of CLONet, the Coastal Lakes Observing Network, which Erin mentioned. I'll just go quickly through. Well, Erin mentioned this enough. What I want to do right now is take you all through the data app that we've created using the data that you all have collected and just orient you to what's there and how to use it. How do I get back to my cursor? So this is the link. And I'm just going to go through and I'll say, I'll orient you to what's there now, and I'll say that I'm very open to suggestions, although I know some of you have made suggestions, I haven't done anything yet. But I'm open to suggestions on how to recode the stuff that's here to suit in different lake needs. So this is the opening page. It's called the CLONet Data Explorer. This is a link to our CLONet website, the Monmouth website, and there's a link back to the Explorer app from there. This button here will download all of the data that's used to make every plot that's currently on this app. So you can recreate anything, you can extend further, you can use the data in a report, whatever, it's all there. It downloads as a CSV file. And I do want to point out that currently, how many people have go to the lakes and sample here? I want to give you a round of applause because this is how much data you've collected to this point. 1,344 samples have been taken across this is just the citizen data across the 10 lakes. So that's available. This page plots all of the lake's data, focusing on the temperature, water temperature, dissolved oxygen, the Secchi depth, and the conductivity. Temperature you're probably familiar with, but I'll give you some ecological context for each of the parameters. Temperature we keep track of for long-term trends that might indicate climate change, so peak summer, minimum winter temperatures, stuff like that. Duration of temperatures. Dissolved oxygen, as Erin mentioned, is an essential part of all aquatic ecosystems. Things die quickly, as quick as you and I would if we didn't have oxygen when there's not oxygen. The Secchi depth is, on the face of it, a measure of water transparency, but there's a long historical record of using Secchi depth as what's called an indicator of lake trophic status. We know that lakes that are in trouble tend to have very low Secchi depths, and that the healthier of lakes tend to have deeper Secchi depths. There's a lot of data from around the world, dating back to the 1800s again, that supports that kind of analysis of Secchi depth. And then conductivity, which is a measure of conductivity which can indicate salt or other things in the water. Particularly for our coastal lakes, salt is a big cause of conductivity. So I say I need to learn how to code a page so it fits on the page, but the other thing you can do with this is choose a time range here to look at. And one thing I'll illustrate here is that if I move this window back to the COVID pandemic, you'll notice that although the state labs were closed and nobody was looking at coastal lakes from the state during that period, our samplers were still out there taking data. So for that particular period, I've got January to August. We don't have any state data, but we do have citizen data for that period. And it shows the resilience of citizen sampling. Here, this page just allows you to select a given lake and look at it in comparison to that black line, which is the average of all lakes. So if you're interested in one lake or another, you can choose it from the drop-down menu here. And I apologize if I haven't added Jackson Woods yet. I'm getting there. And look at that compared to the average. And you can see things like Wesley tracks the average temperature pretty well, also tracks the average dissolved oxygen pretty well. The conductivity of Wesley tends to be below, but we do see these spikes of conductivity in Wesley Lake, which are from road salt intrusion, because there's no other way salt gets into Wesley Lake. And you can also slide the window here. Another way of looking at the data is just to say, okay, what's the average per season in a given lake for the different parameters, instead of looking at a time series, and that's what these show. And it's separated out by season here because we know that the number one source of variability in the data here is season. Summer is going to look different from winter, of course. So you want to look at summer data separate from winter data, et cetera. And that's what all of these are. So here you see, so Jackson Woods is here. You can see some differences in lakes. Let's go to the Secchi depths. This is, to me, the most important measurement that we make. You can see the range of different Secchi depths that we see in different lakes that tend to be consistent within a lake as well. I'm crazy about rainfall. I think rainfall is a really important driver of the condition of the lake, so I added a graph here which steals data from the NJDEP rainfall site here and updates itself every time this page updates. The rainfall graph updates here, and what you're looking at is the gray line is the average, the long-term average, how rainfall accumulates in the coastal lakes area. The green line, or chartreuse line, is the actual data for 2022, updated hour by hour as quickly as the state updates. And you can see here from June 1st through, anybody remember what hurricane this was? I think it was Ida? Ida. We were in a drought over the summer. So rainfall is not accumulating. The line's going across the graph instead of up the graph. It intersects and crosses the average line. Then we get this big rainstorm. And then since then, we've kind of had a few storms here and there ratcheting up. And lo and behold, we're average now for the year. After everything. After the drought and the hurricane, we're average now for the year. And then the last thing that I just started working on are these sampling maps for different citizen sites. So You can choose the parameter, and the size of the circle represents how many samples have been taken there, because that's important. As Erin mentioned, we have citizen samplers that come and go. So sometimes we have a lot of samples, sometimes we don't. And when you click on it, it tells you where you are and the average temperature for that season. Again, oops. This can be selected to different seasons. So that's, to me, making this was a response to the CLONet objective of feeding the data back to the CLONet sampler so that you not only know what's happening in your lake, but you know how your lake looks compared to other lakes in the system. And again, I'm open to suggestions on updating that, which I will get to. Some of the key takeaways from the citizen data so far are the simple measurements of temperature that we've made for 4 years now over the summer show that Deal Lake is warmer than it used to be. Or not, the coastal lakes are longer than Deal Lake used to be, or warmer than Deal Lake used to be. So there's a 1977 report on Deal Lake where they measured water temperature around the year, and our current coastal lakes water temperatures exceed their maximum temperatures by 5 degrees or so, which is consistent both with climate change that's occurred between the 70s and now, and with shoaling of the lakes, which would cause them to heat up more. Our dissolved oxygen measurements show generally okay, but that's not surprising for daytime measurements of dissolved oxygen. That's when oxygen is going to tend to be high. What happens at night? We don't make dissolved oxygen measurements at night when photosynthesis is not happening, but that poster over there, the furthest to the back of the room, shows experiments that we did this past summer during the HAB in Deal Lake that we tracked 24/7 oxygen measurements, and we showed that Deal Lake does go anoxic at night, and it's related to the harmful algal blooms that occur there. Like I said, 10 minutes of no oxygen is enough to kill most things if they can't swim away from it. So it matters if you even get an hour of low oxygen at night when no one's looking. That matters to the ecosystem. We have established very well how low the Secchi depths are in our lakes, which is an indicator of eutrophication and degradation. But this is also going to be one of our main indicators to track as we go through restoration steps. In other words, as we keep measuring Secchi depths moving forward, we should anticipate seeing if what we do is successful, we should anticipate seeing the Secchi depths increase as this global indicator of lake health and trophic status. They're coastal lakes. They're connected to the ocean in different ways, and we've seen through citizen data that conductivity varies within the lakes. Within lakes, I'm not showing the analysis, but there's a pretty tight correlation between rainfall events, how much it's rained over the last several days to 1 or 2 weeks, and the conductivity in the lakes. Conductivity goes down associated with rainfalls relatively rapidly, which is consistent with this idea that coastal lakes are subjected to heavy stormwater runoff. It shows their connection to the storm drains in the streets. When rain falls, it hits the streets and it goes into the coastal lakes, conductivity goes down. Citizen data has shown that very, very well, and that's a really important finding. Again, as watershed restoration occurs, as the velocity with which stormwater is put into lakes changes, we might see that relationship change over time. That's something that we've measured as a baseline condition that might change over time with restoration. And then there's in the record, there's a few. Wesley Lake is a good one because there's not a lot of good ways for salt to get into Wesley Lake from the ocean. So when we see it, and it does tend to happen during wet winter periods, the conductivity measurements show road salt intrusion events as well. So one of the key questions that I have that I think is really important for CLONet in general is citizens measure a small set of parameters, basically Secchi depth, temperature, dissolved oxygen, and conductivity. We as a lab, in collaboration with the state, measure those things plus a whole host of other things that are really expensive to measure and take lots of expertise and person power to do. So I want to know, as a matter of resilience of our CLONet program, what is the relationship between the citizen parameters and lake characterization that's done in that much more expensive, involved way? I think that's a really important question to ask. And it's important because lab sampling in the program that we have might not last forever. I hope it does. I love doing this. I love being involved with you all. But it's expensive, and we're always looking for money to keep it going. And then there are times when we don't have access, like I mentioned, to state sampling or labs, like during the COVID-19 pandemic. But we do have enough data at this point to allow a rigorous look at the relationship between citizen sampling and lab sampling. That's what I'm going to talk about next. I did a statistical analysis. Don't worry about that unless you really like principal components analysis and multivariate statistics. That's what's behind what I'm going to tell you. And I focus this analysis on how do the things citizens are measuring relate specifically to the state and the lab measurements of nutrients, which citizens don't measure, but are really important, and algal biomass, like HAB biomass. And the upshot is that citizen Secchi depth has a relationship to total nitrogen and total phosphorus, inorganic phosphorus, phosphate, and phytoplankton biomass. The way you interpret that from this plot is things that are grouped together are positively correlated, so they go up and down together. This group of lab parameters, total nitrogen, total phosphorus, phosphate, PC, RFU, which is the HAB biomass, and chlorophyll A, which is also HAB biomass. And they're opposite Secchi here, which is the citizen Secchi depth. So that's saying that when Secchi depth is low, and this is all done through connecting the lab and the citizen data sets using seasonal averages for each lake separately. It's saying that when you measure a low Secchi depth in a lake, it coincides with us measuring high nutrients and high phytoplankton / HAB biomass. And that's important because that's making a statistical linkage between what citizens are measuring and what we're spending a lot of time and money to measure separately through laboratory analyses. Further, in this axis here, citizen temperature measurements, because it's opposite, are negatively correlated with dissolved inorganic nitrogen and, to a lesser extent, oxygen. This reflects a seasonal dynamic that's common to most of these coastal lakes. In the cold time of year, when temperatures are low, the lakes get flooded with nitrogen from the watershed through the wet winter and spring periods. And we've seen this in we actually have a paper that's being published that details this in Deal Lake, and citizen data is showing a similar trend. So this is capturing the seasonal nutrient inputs. Does anybody have any questions?
Can you explain that a little better, what you just said?
I don't know if I can explain it a little better. What, just the last part of the whole plot?
Just the last part.
So, this here is citizen scientist measurements of lake water temperature. And in this plot, it's coming out opposite of dissolved inorganic nitrogen, which includes nitrate and ammonia. These are
What's inorganic nitrogen?
That's the nitrogen that comes off the watershed, the plant food, the Miracle-Gro type nitrogen.
Gotcha.
Yes. And it's saying that statistically, there's a relationship between our measurements of that nitrogen and your measurements of water temperature.
That I understood. I just didn't-
Yeah, okay. Any other questions? Yeah.
Yeah, so you mentioned that, the miracle grow and those kind of things, right, would affect the nitrogen level, right? Why in the winter, though, do you see an increase? Because are people not using that kind of stuff in the winter, or is there something else that's causing that increase in nitrogen?
That's a great question. So fertilizer is not likely to be the biggest source of dissolved inorganic nitrogen coming into the lakes. But there's also the uptake. When the water is cold, things aren't growing and removing that DIN from the lake either. So that's also part of the reason why it accumulates. And then there's a whole phosphorus kind of dynamic. Also, Matt, did you have?
Yeah, no, I agree. I think in the winter time it's cold and it's not being used, so that
Yeah.
of course, I didn't expect the negative relation between the two. Yeah, that was,
Yeah, the paper that we just published that's coming out basically shows really strongly, and this is just for Deal Lake, a huge glut of inorganic nitrogen coming in the winter, spring, and then that's drawn down in the summer, and you get algal biomass. It's transformed into algal biomass, basically.
And that's due to a lack of movement of the water? Frozen or?
Part of it is a lack of biological activity that's going to take up the nitrate that's coming in. When it warms up, you get more activity, stuff growing, taking out the nitrogen and using it. So it doesn't accumulate. One of the things that we started this past year was adding to some citizen toolkits a fluorescent probe to measure harmful algal biomass directly. And the question here is, can a citizen science monitoring program actually measure HAB biomass, which is a very important parameter for the state? They keep track of that. We all keep track of that in a reliable way. And I've addressed that question here by showing the relationship between, on the x-axis, the citizen fluorescence measurements. How many people here have a fluorescence that they use? Right on. And Erin's measurements using the cyanofluor, which is a different type of fluorometer that we've used routinely. This line here marks on the cyanofluor scale the point at which that corresponds to the amount of HAB biomass that the lake would start to consider a problem. And you can see that for the most part, our measurements line up with each other and make a line, which is good. But you can also see that there are some measurements in Spring Lake. Is anyone here from Spring Lake? I'm not calling you out. I'm just saying that we got to connect. I didn't notice this in the data before, but it might be your probe. Your fluorescence is measuring very high values when we're measuring lower values. These here. So just that's a typical common thing to have to deal with in citizen science programs. That's why we do these sorts of analyses. So Erin and I will catch up with you and maybe replace your probe. But for the most part, we're getting a good line, and this indicates that we do have a citizen program that's capable of measuring HABs in lakes. Citizens, I think we can support that. And this is important because here you're looking at time series, animated time series of HAB biomass in Deal Lake up here, which gets them every year, and Lake Takanashi down here, which, as you'll see, has never had a HAB observed in it. The vertical lines are June 1 through October 1st each year, the HAB season. And the color of the lines is coded to the water temperature. So you can see that during the warm time of year is when you get HABs in places like Deal Lake. And Takanashi doesn't get quite as warm, but doesn't get HABs. And if you want to know when a HAB's going to occur in Deal Lake, it's June 12th, more or less. Somewhere in the second, third week of, oh, sorry, July, not June. Or it's been that way for the last 4 years. Yeah.
So the rainfall graph that you put up before that showed the drought,
Yes.
so what was happening during that? Did we glean anything from that period? What was happening in the later paths?
In my estimation, we had a really wet late winter spring 2022. June 1st, someone shut off the spigot, and it was dry and hot from then until Ida. And that's when we saw major HABs occurring in a lot of lakes. Is that what you're asking?
Yeah.
Yeah, so I think,
That was kind of anomalous, right? That period?
yeah. But I think that was preceded by a very wet period is important. So January through June was relatively wet. And we can go back and look at that, but maybe later. So here, these plots are showing on the different years of the HAB lines, HAB biomass in different lakes, for each lake with the reference, the DEP reference line here for reference. And so we know after 4 years that places like Deal Lake always get HABs. Wesley never does. Wreck Pond, never seen it. Sylvan, we've never seen a HAB over the line there. Sunset is off and on. Fletcher had never had a HAB before, but this year was off the charts. Actually, the highest level we've recorded in the 4 years we've been looking. All of a sudden, in Fletcher, where we hadn't seen a HAB before. Also, Marty, I think, related to the drought. We use that data to count up, of all the days that Erin samples, how many of those days were spent in a state of HABs? We get this chart here. Sunset Lake, more than 20% of the times we visited it, Erin's visited it, has had a HAB in it. And then there's places like Deal Lake, up 15%, 10% for Fletcher, and about 7% for Silver. And then there are all these lakes that don't get HABs at all. They have different water quality issues. The happiest areas just happen to be in Asbury Park. And no, I don't think rock and roll causes HABs. It's a thought, you know, crazy rock and rollers. But what we started to do is look at watersheds of the different coastal lakes more closely. And it's another statistical analysis I'm going to summarize here. The lakes that get the worst HABs and the most HAB days in a year tend to have the highest population density within the watershed and also the highest percent urban land use, land cover in the watersheds. By contrast, the lakes like Tackanassie especially, that don't get HABs and have relatively better water quality tend to have the higher percent of wetlands in their watershed, land use, land cover. So they have a different watershed. So this link that we've made between water quality in lakes and land use, land cover in the watersheds, I think should give us some direction towards how we restore these coastal lakes. I don't think we can change the watershed, but we have to think about what do wetlands do for a lake and replicate that. I'm not an ecological engineer. I'm excited to be working with people like Marty McHugh who know more about how to make that happen. I just measure stuff. But one of the things we have to remember, so I've been talking about HABs because they're an important public health issue. These are small lakes, it's a relatively small system, but the amount of people that spend time around these lakes makes the public health implications of having toxic, harmful algal blooms in the lakes all the more important. And not just the people that are here now, but the people that are here in the summer when our population explodes and they're all spending time around these lakes. I think that's an important issue. So whether we're thinking about dredging or amendments, adding hydrogen peroxide pellets to lakes to clean them up, or using nanobubble technology, which is a type of technology that I think has been employed in Deal Lake and is being used experimentally, We want to know, how do we use CLONet data for restoration? And I think as we're writing proposals and thinking about how to get money to do this, the fact that you all have participated in CLONet and helped to collect this data that I was presenting shows a commitment that's going to mean something to the funding agencies, a commitment to lake stewardship. It also shows that we have a grasp of what the problems are in different lakes. Some lakes don't have problems with harmful algal blooms. That's not the target issue, but others do, for instance. And then it shows, which I think is a really important aspect, that we have the infrastructure in place between what citizens sample and what my lab samples to monitor the efficacy, how well restoration strategies are working. And everybody learns about restoration strategies in that way, what works and what doesn't work. Yes? Yes, yes. Sorry?
If there are fountains in the lake, what are the aviation techniques?
Fountains in the lake are mostly, as I understand, what's called aesthetic decorations. Yeah, but if you really want to mix air, you'd put the bubbler on the bottom of the lake and mix like that. I don't know if the fountains that we have in coastal lakes have an effect on aeration. So I'll stop there. Thank you. We have a break after this. I'll take questions then, or I'll take a few questions now if anybody has some. Thank you. Mike?
Quick question. You said that the lakes are warmer today than the 70s. You said 5 degrees. Is that 5 degrees centigrade or Fahrenheit?
Centigrade. It was centigrade.
Centigrade?
It was a big, big difference.
You're saying that in the 70s the lakes were around 65 degrees.
I can't do that conversion in my head. All I can do, Mike, is show you the DEP report that I'm working from. I've been surprised how difficult it is to find other Deal Lake historical temperature measurements. But this one report from 77, 78 measured temperature around the year, and their peak temperatures were like 20 to 22 Celsius or something like that. And we measure 25 to 30 Celsius routinely. We have measurements that are over 30 degrees Celsius, in fact, in a number of lakes.
Now, second question is, if you go back to 1888, which was your first slide, most of the lakes were connected to the ocean, so there was tidal influence. Now, as we developed, we've made every one of these lakes into a retention basin. They're not connected to the ocean. Direct ponds, the APD ocean. What's the influence, and if you talk about restoration, should we open them back to the ocean, or?
Well, a lot of them are still connected to the ocean. It's not just Wreck Pond.
Just ideal. Well, they're connected
Yeah.
by tide.
You know, I'm excited to work with people like Marty because I don't have the answer to that question. Flushing would not be a bad thing in my opinion of these lakes, but you have to consider the other uses and the other reasons why they're not connected anymore.
You're myopic, that's why they're not connected.
Sorry?
I said you're myopic, that's why they're not connected.
Yeah. I mean, if you want to go for the pristine state, then we do have an idea of what that looked like right here.
Well, we blocked off Wreck Pond to control flooding. High tide sands have shut it, so the water doesn't come.
Yeah.
Jason, I think you also said something about shoaling. Shoaling? What has a difference?
So I don't have really good data on lake depth from a long time ago. Just kind of anecdotally talking to people who've been around the lakes for a long time, they used to be deeper. So when I'm trying to wrap my head around, so assuming that the data from the 70s is correct and good, that they didn't have a broken thermometer or something, it was a DEP report, so it should be quality data, high quality data. I think what could have caused the warming? It's too much of a change to account just climate change, although there has been a 2 to 3 degrees warming over that time period of air temperatures. But if the lakes, if I'm hearing anecdotally the lakes are filling in with sediment and they're shoaling, that a smaller volume water under the same solar radiation is going to get hotter.
And it seems like it's a perfect storm. Right?
Yeah.
We haven't done anything with our lakes to deal with sediment management. We've built all around it so you have all this impervious surface that's heating up, in the summers. And then you have tremendous rainfall, right? It's like a perfect storm.
Yeah.
Just heat.
So that aspect of the basically the urban heat island kind of effect, if our watersheds are mostly blacktop and tar, you would think that you'd be adding more warm water every time it rains.
And you can see, I've looked at maps of tree canopy over a 100-year period too. The tree canopy is shrinking, so that's another,
Yeah. So I look forward to these conversations of using this data and everything we know and more stuff that you all know about the lakes that I don't know about the lakes for restoration. I think it's a really exciting point we're at now, moving towards that. Oh, Gail.
Hi. I was wondering if anybody from NJD is here.
They're closed on election day. They were invited. I've communicated with them. They sent their regrets, but we goofed. I didn't know state offices were closed on election day. I thank you all for being here on election day, by the way. I hope you did get to vote still.
So my question is, and I was hopeful that they would be here. So Asbury Park, as we all know, is going through an enormous amount of redevelopment, which is definitely affecting our lakes, and it's going to continue to affect our lakes. So our city manager and council people met with NJDEP recently, and we were told that the definition of our lake, Wesley Lake, was changed to fluvial. So our old city manager always called it a detention basin. He refused to call it a lake, it was just a detention basin. Now DEP is referring to it as fluvial. Nobody seems to know what fluvial means or why the definition was changed. And if that means that some of our lakes come from springs, some of them only get their water from the ocean, some of them only get their water from storm water, which is mostly us. So are we seeing that affect the data? Do we have information on that? And does anybody know what fluvial means?
I thought fluvial meant that it flows.
That
Yeah.
makes sense, right?
Yeah.
So, but Wesley Lake does not have a spring. It gets most of its water from stormwater, which could make it.
But it does discharge to the ocean.
It does.
Yeah.
And some ocean water comes in. So is that just at all like how any of these coastal lakes get their water or what the water interchanges with?
Yeah, that's what we've started to focus on. So there's a professor here named Jeffrey Fuad, and actually a student who started in my lab as undergraduate and then did her master's degree here, continued to work. They did the watershed work. And we've started to look very closely at all of our citizen and lab data and how that relates to what's in the different watersheds of the different individual lakes. They're mapping watersheds down to the scale of each individual lake in the system. And they're able to, and then that allows us to do the analyses like I showed here, that turns up results like, the worst lakes in terms of HABs happen to be where there's the most people in the watershed and there's the highest percent urban land use in the watershed. The better lakes tend to be where there's, to some extent less people in the watershed, but a higher percent of wetlands in the watershed. So, if you want to make an argument against further urban development and that's going to impact aquatic environments in the area, this data set supports that and might lead to, I think the way those things work is that you might be able to convince the state or the developers, I'm laughing at myself saying that, to put money into remedial action because we have data showing that if they're increasing the urban footprint of the watershed, that might have a detrimental effect on the aquatic environment. You at least make that argument. All right, let's talk on break because it is break time, and we also have time during lunch to talk. Thank you again.